For thousands of years, humans were busy with his own problems on Earth. But then someone turned his telescope to the sky and things changed forever. What Galileo Galilei saw in space since then, we humans have increased interest in looking at space. Hubble Space Telescope launched in low Earth orbit on April 24, 1990. The Hubble telescope changed humans' view of space. Since launch, Hubble has in its 30 years given us distant planets, stars, moons, exoplanets, supernova, nebula, star cluster, black hole, has investigated galaxies. Hubble has given more than 1 million images so far from his observations. Hubble telescope leads to breakthrough in astrophysics. It is only the Hubble Space Telescope, due to which the rate of expansion of the universe, and the age of the observable universe is determined. Hubble Space Telescope may continue to work until 2030 or 2040, but his unique research in space will always be remembered. James Webb Space Telescope. This telescope is a unique piece of science and engineering. Created by a team of experts from NASA, Canada, Europe in international collaboration, James Webb Space Telescope named after NASA's second chief head named Sir James Webb. Under his supervision, 1961 to 1968. America's first manned space missions were carried out. The James Webb Space Telescope is a lightweight telescope, weighing 6.2 tons. The same Hubble telescope weighs 11 tons. That is, James Webb Telescope weighs about half as much as Hubble. With which James Webb Space Telescope will be able to do excellent work in space. In comparison to size, Webb is equivalent to a tennis court and is about 3 stories in height. The same Hubble as a school bus. James Webb Telescope's primary mirror has a 6.5 meter diameter. The same Hubble's primary mirror has a diameter of 2.4 meters. Because of this large primary mirror, one can easily see Penny from a distance of 40 kilometers. James Webb Space Telescope's primary mirror is made of beryllium, which is lightweight and maintains its shape even in low cryogenic temperatures. Beryllium is coated with a thin gold coating, in which only 48.25 grams of gold has been used for coating the entire primary mirror. This gold coating is as thin as 100 nanometers. Gold has been used because gold reflects very good infrared radiation. The resolution of the telescope is limited to the number of the wavelength it can fit in its mirror. This means a larger mirror will give higher resolution. That is why in making James Webb Space Telescope, the largest mirror has been used in comparison to all telescopes launched in space. This large honeycomb mirror is made up of 18 hexagonal segments. For this reason, this huge telescope will give a clear image from the light of distant galaxies. In addition to the primary mirror, the telescope may also have a perfectly rounded small secondary mirror, which will receive light from Webb's primary mirror and pass it to the camera and scientific instrument behind the telescope. 2 more curved mirrors have been used to further improve the quality. The James Webb Space Telescope is designed primarily for observations in the infrared spectrum. But apart from this, the telescope will also be able to see the red and orange visible lights. Infrared, this is heat radiation, so every hot item including telescope is emitted infrared light. To observe in the infrared spectrum, the telescope will have to be cooled down to -230 degrees Celsius temperature. Otherwise, the infrared radiation from the telescope itself will interfere with the clarity of observations and image. The James Webb Space Telescope is going to capture the faint heat signal of distant objects. So this telescope has to be kept cool. and sun shield is being used to protect it from the light like the sun, earth, moon, and from external sources of heat. The sun shield is the main part of the James Webb Space Telescope. The length of the sun shield is 20.197 meters and the width is 14.162 meters. The shield is made from Captain E. This shield is made from Captain E in 5 very thin layers. This layer is as thin as a human hair, and each layer is coated with aluminum from both sides. And the sun-facing side is coated with doped silicon, due to which it will reflect the heat coming from the sun into space. The reason for which telescope mirrors and scientific instruments will remain cool. This means that one side will be as hot as a cake in the oven, and the other side is even colder than making ice cream in the refrigerator. The third main part of this observatory is the Integrated Science Instrument Module, ISIM. It can also be called the heart of the James Webb Space Telescope, which has the main payload camera and science instruments of the telescope, in which the most important NIRCam, near-infrared camera on which the main focus will be. This instrument will give views of the oldest galaxies. Will give the information on the distant star and its planet's atmosphere, and will also help in finding the dark matter with the help of gravitational lensing. NIRSpec, near-infrared spectrograph, will check the physical and chemical properties of the objects. MIRI, mid-infrared instrument, will be able to see stars being born, and a lot of unknown objects in the Kuiper belt, and hope that it will also help in the research of the 9th mysterious planet of our solar system. NIRISS, near-infrared imager and slitless spectrograph camera, aims to discover exoplanets and the first light of distant objects. FGS, Fine Guidance Sensor. The aim is to point telescopes with accuracy, which results in higher quality images. The James Webb Space Telescope will be launched on an Ariane 5 rocket. Webb will be launched from Arianespace's LA-3 launch complex at European Spaceport located near Kourou, French Guiana. The telescope is very large in size, so it will be folded to make its place in the rocket, and while deployed in space, it will again be unfolded in its main form. James Webb Space Telescope will be deployed on Lagrange point 2 of Sun and Earth, where at L2 point the telescope will work well in deep space, leaving behind the disturbance of Sun, Earth and Moon. James Webb Space Telescope will orbit the Sun instead of the Earth. The L2 point lies outside Earth's orbit while it is going around the Sun. Keeping all three in a line at all times, it also helps for better communication with Earth, as all three in the same line, because of which the sunshield will be able to block the solar wind coming from the Sun, infrared radiation, and the light coming from the Earth. The difference from Earth to L2 point is about 1.5 million km. The distance from the Earth to the Moon is about 384,400 kilometers. And the distance from the Earth to the telescope will be 4 times of it. The combined gravitational forces of the Sun and the Earth can almost hold a spacecraft at this point, and it takes relatively little fuel to keep the spacecraft near L2. Hubble orbits about 547 kilometers above Earth. Hence its servicing machines became possible. But the James Webb Telescope is far away from Earth, so the possibility of its servicing mission being difficult, and from current technology, it is very impossible. Because this telescope is completely self-sufficient, after deployment in space, it will have to carry out operations by itself. So scientists and experts cannot make any mistake in making it, and this is the reason why there is a delay in launching the telescope. Hubble telescope can see UV, visible light, and to some extent near-infrared spectrum. But the wavelength of light coming from distant stars and galaxies, which has been stretched into infrared radiation, to receive it, is out of Hubble's capacity. The same Webb will be able to receive this infrared radiation, and due to which, we will be able to see distant objects easily in the universe. It is estimated that, James Webb Space Telescope will show us the universe, 100 to 250 million years after the Big Bang, in which you can see the star being born. Even though it may not exist, yet, due to incoming infrared radiation from it, we will find the secrets of Big Bang and the birth of stars and more. The most compelling goal of the telescope is to search for planets like Earth and analyze their environment. The telescope is designed to work for 5 to 10 years but will continue to work for a few more years. NASA says that this telescope is 100 times more powerful than Hubble. But why is the telescope being deployed in space instead of the Earth? Why it is not ground-based on Earth? Due to Earth's water vapor and other elements, such as the Earth's surface to absorb much cosmic radiation, problems will increase when noise and vibration will come under the cover of observation. But there will not be any problems in the space, due to which, the telescope will get high-quality images. We are all eagerly waiting for the James Webb Space Telescope to be launched, but work on integration and testing of the telescope was suspended in March 2020 due to the COVID-19 pandemic, adding further delays. But we still have to wait till October 31st, 2021, cause the fruit of patience is sweet. Probably James Webb Space Telescope will answer the biggest question of humans. Are we alone? Let me know in the comments, what would you like to find with this telescope? Thanks for watching.